This presentation, as I said, it's courtesy IVHCO, which is a Illinois-based company in US, Illinois Valley Holding Corporation. Mr. Brett is the president for this company, and there's an essay paper in 2015 which talks about this. So anybody interested can get hold of that paper and see those details. This September 2016, Brett was in India, and we had some discussions with the OEMs, and probably I hope very soon some practical trials tests will start in this direction. Okay, let me describe what this technology is. As I said, it's a cool particulate regeneration. We have named it as a CPR. Basically because you are not artificially raising any temperatures. Therefore, we never wanted to use a low temperature word. It doesn't mean it's cool or it is cold. It doesn't mean that. It means the naturally occurring temperatures is what is happening to the CPR regeneration technology. No artificial addition of any temperature. So this we think is the best option for India. First, it is low temperature, the naturally occurring temperatures. So you can start with a very high NOx engine, that is with low EGR or no EGR, exhaust gas recirculation. We can use vanadium, SCR and DPFs. We can also use single brick where DPF can be coated with the vanadium catalyst, because you have not raising temperatures now DPF for regeneration. So you can do in a single brick. And it can work on all duty cycles. Basically, if you look at any regeneration cycle, the exhaust comes into DPF, and after DPF, the temperature of exhaust increases because DPF burns carbon and the temperature goes up. The second advantage and the best advantage of this technology is that you can take any engine, whether BS2 or BS3, and you can raise it to BS6 level. Because what you are doing is you are capturing carbon and removing it. So capturing carbon and burning it has a lot of difficulties in an engine. So it is that way very friendly technology. And the main advantage is it is also fit for retrofit. Retrofit means the existing population of vehicles, which are bad smoke giving vehicles. You can take them, fix them with a DPF, and you regenerate in this process. You can get them clean exhaust as US6 or BS6. While the conventional technology, which we have discussed in the first half of this lecture, you need elaborate systems. You need temperature management, which is a engine ECU function. You need a 7th injector and all those things which have to be controlled. That is not so easily adaptable to a retrofit technology, to an old engine. So this technology is good for old as well as for new engines. So it is low temperature DPF regeneration without efficiency loss. So far as whatever temperature regenerations we saw, they had some efficiency loss. Efficiency means in terms of fuel efficiency loss, because some fuel was needed to raise the temperature. And the thing is, it challenges the current thinking and current practices. It's a new innovative thought, altogether different. Therefore, like any new thought, there is little acceptability on face of it. So we are encouraging people to, invest into it, into investigations, and, try it out and see that it works. There are issues, whether the durabilities and things like that. So all this will happen. This happens with any technology, whether you take Euro 1, Generation 1 Euro 6 or Generation 2 Euro 6 of Euro, bring it to India, try on your engine, you still have some teething problems. So that type of problems can also occur here. We are not denying that. But that is what makes us, it motivates us to do experimentation with this technology. So in this second part, I'll do CPR overview topics. What I'll do is why CPR is important for India. I'll try to answer why we should prefer it. Then some fundamentals, how the principle of how it works. Then it has been tested on some generators. Their testing results I'll show. Then we have done some work with the Volkswagen Jetta demonstration vehicle in US. And then finally summary of this. Unfortunately, we have not done any work so far in India because we are looking for an OEM support or a research institute support for doing this work. So what is India's need for CPR? Why should we be promoting it and looking at it? BS6 equivalent to generation 2 Euro 6 emissions with low cost engine after treatment. The underlying question is, we are a cost conscious country. Now, if you look at it, the after treatment technology of Euro 6 engines, compare it to Euro 3. The after treatment technology, that means this DOC, DPF, SCR, ASC, integration, fuel injection systems, urea injection systems, this after treatment system, this is more expensive than the engine itself in the BS3. In BS6, engine will be still expensive, so it will not look that proportionately high. But the point I'm trying to say is that this technology of 4 catalysts together is very expensive, more expensive than the engine itself. Now, is that you can afford to do? Second thing, there's a jump in cost of engines if you go from mechanical injection engines to electronically controlled CRDI engines. Okay, you can never have the conventional DPF approach, conventional SCR DPF approach without an electronic control injection, without a CRDI engine. It will not be possible to have that system. You can't bring PM to that level and NOx to that level where you can put an effective cost-effective technology. But if you go for a CPR type of thing, which is a physical process, which is not a chemical process, you lodge the particles on DPF, you dislodge them, which is a physical process. So what you can do is you can have very low cost of the DPF after treatment system, plus you can work with old mechanical engines itself. What is your aim actually? Aim in this country is to improve air quality. To improve air quality, you want to bring down the emissions. Now, why we should be talking? We should be talking about the emission level. Okay, we should not be talking what type of engine should happen or what type of automotive catalyst it should use. So far as we meet our end of emissions, tailpipe emissions to our legislation levels, whatever technology we use, we should be happy. So if you take a mechanical injection engines today, like they are used in tractors or some old Tata trucks and things like that, new vehicles have started coming with, of course, CRDIs. Then that low cost engine and low cost after treatment becomes our solution. Now, we should have a DPF regeneration technology which is capable of type of our operation, like the dense cities, the city of Delhi or Pune or Bombay, where traveling, or Bangalore, where traveling speed is very low. So in that, and very fast stop and start services. So in that type of low speed, low temperature driving conditions, which are very peculiar to India, we should have a good DPF regeneration technology. I understand in a Euro 6 engine, once you start regeneration process, it takes almost 20 to 30 minutes for regeneration to complete. Okay, and imagine that to happen in India. If you have initiated, the system automatically has initiated a regeneration system and the vehicle stops because the next time red light comes in front of you. So that halfway it is done and left. This is more dangerous in terms of thermal shock to the catalyst. So the damage of the catalyst happens faster in that scenarios. So we should have a very stable regeneration technology which can work in the type of conditions we have. We should have short DPF regeneration time, not 30-20 minutes. We can't afford in any city driving that type of regeneration timings. Then real world BS6 emissions at low speed beyond certification cycles. See, our certification cycles in India are basically driven from Europe. or nowadays they call it word harmonized cycles. Like for trucks and buses, we have WHTC, WHCSC, word harmonized steady state, word harmonized transient cycles. Now these cycles are on the higher speed ranges and load ranges, which does not happen in our country. So real world emissions, even if you control emissions of vehicle by an engine selection technology, by a after treatment selection technology, and pass an ARI type of certification, you still run a risk of doing very bad air quality management into the real world when the vehicles are driven on road. Then, as I said, this is a technology which does not require ULSD. ULSD is welcome if you have taken a decision as a country that we will go for ultra low sulfur diesel. That means less than 10 ppm sulfur diesel in 2020. Okay, it's welcome because it will generate less particles, particulates and things like that. But it was not necessarily required. Even if some sort of adulteration happens, our system can still handle it. Then improved fuel economy. What I'm trying to say is it is improvement over the conventional wisdom. Conventional wisdom of generating DPFs, regenerating DPF. It won't improve the fuel economy of the base vehicle. Base vehicle fuel economy actually deteriorates after treatment is kept because you have fuel injections and things like that, 7th injector. But here you don't need that. Then the acceleration drivability will be very, very great in this, which we need in type of our driving cycles. Say, when there frequent stops, like in Indian cities, there's a tendency to accelerate fast to reach your time and your destination in time. So you have high acceleration, high deceleration, and frequent stopping and starting in this country. That's our driving cycle typically explained. So what happens to DPF? DPF generates a back pressure. If you delay it too much, then higher back pressure comes up, and that the acceleration drivability becomes inferior. So CPR is a technology which will quickly, shortly, in small intervals, changes. And then another thing is it is retrofit possible solution. So it can go with new design as well as with old design. Say at any given time, if you see, let us say in 2020, how many vehicles will be Euro 6? Only 10% of the vehicle park. Our production is not more than 10% of the current population of vehicles, assuming that. So at any given point of time, 90% vehicles in 2020 will still be BS4 or BS3 or BS2. So this, we don't have a scrap policy in this country, though government is trying to bring it. So any years of old vehicles continue on the road. And in a way, in a socially different country than luxurious countries like US and all, we have to be sensitive to people's need. Here a truck driver, sells gold jewelry of his wife and buys a truck and runs it. That's the typical scenario in India. That's how truck management is. Only 5% trucks belong to the big companies. 95% trucks are single owned, or 2 or 3 persons put together their money to own a truck. Now, if the government says throw this truck after 10 years and does not give them a good compensation to buy a new or good discount to buy a new one, I mean socially not practical. It is killing him practically. I mean what you hear about farmers committing suicide in Maharashtra or somewhere, they bring the scrap policy and find truck drivers committing suicide or truck owners committing suicide because they don't have money. They don't. No, these are socially, we should be active about this. So what I'm trying to say is there is a technology which will go for retrofit. So you need not scrap vehicles as the new policy, new government thinking goes around. I won't say, but I won't hesitate also in saying that yes, who gains? The auto companies will gain because they will sell more. But the poor man will not gain by this. His livelihood affected.
After using the vehicle, after 10 years, the after sale will be reduced.
Yes.
So it will be only a scrap.
No, didn't get your point.
Saying that after 10 years we won't be using this engine
Yeah.
of this truck, of this
Yes.
specification.
Yes.
So it will be a scrap after 10 years.
Yes. So do you want a scrap? You don't want, no, because there's a poor guy. If he does not get a good scrap value for his vehicle, he can't buy a new one. Yeah. So we don't want to be scraps. That's why I'm not for a scrap policy. I'm saying maintain it in proper condition. Overall, the engine, have checks on this, that your engine is good, your fuel economy is under control, and then you have emission under control. So take out technologies which can also get adopted on the old vehicles. That's the retrofit we are talking about.
BS6 implants can be implanted on the old BS2 trucks also?
Not all, that's what I said. But this is a technology which can be implanted. Because here, it is solution for both. In that there was a lot of electronics involved. You know, like you have to burn at a particular temperature, you know, so that you have to give 6th, 7th injector or post injection. So ECU comes into the play. Now all old trucks, mechanical injections, they don't have even any ECU, not even the governor, electronic governor. They are mechanical governors, mechanical injection. So how do you electronically control them? So it is not possible to bring the conventional wisdom of knowledge of after treatment to the old vehicles. You can use catalyst, there is no doubt about it. Catalyst can be used, which go to new or which go to the retrofit will be the same. But the total system integration will be much more challenge. And then the cost will go up again. So retrofit also to be a cheaper technology, then only a poor old truck owner will have it. And then it's already a country where temperatures are high, ambient temperatures. Okay, in Delhi you can touch 45, 47. Now, if you have an extra fuel getting burnt into the injection systems, the whole exhaust systems become very red hot or very, you know, very hot. So then there are chances of somebody, you know, accidentally touching that silencer or something like that, burning. And the kids play, you know, truck चल के आया, ट्रक के बराबर खड़े बच्चे छूते छूते जाते हैं उसको लाइन खींचते हुए. Somebody touches the exhaust line, which is very hot because now you have deliberately put the exhaust hot to make the DPF work. So that can be accidental issues. So there is a low temperature operation which is also possible in CPR because you are not raising artificially the temperatures. Then reduction of removal has maintenance. Now, this is something which can be done on both, but the new vehicle and the old vehicle and other technologies also. But what you need to do here is you have to remove the DPF and you know, remove the ash by scrapping and things. It's a little difficult, but I think if you manage using low ash oils, you are better off in handling it. So now let us come to the fundamentals, how the pressure pulse works. And this was the question one of the satellite participant asked, the lady participant. Okay, I'm giving you an example here of a single chain. Actually, it's a honeycomb structure in a DPF. Honeycomb is really like a honeycomb through channels and things like that, like wax honeycomb. So I'm taking one channel to explain you. So this is suppose a rectangular channel. It has to be closed because DPF has to trap all the particles. So it has one end closed and the channel, through the channel it can pass through and then goes to the next channel and that's to the exhaust. So this is the channel. So first step is to understand how the channel is filled. So we are trying to say filling. So what is happening? The exhaust is coming from the side of the channel and goes out. Okay. So what was the carbon soot? They get trapped and therefore you have the black two layers coming up at the you know, filling. So time and time they keep building up micron to micro levels and things like that. So initially they don't disturb engine. There's no back pressure issues. But as it keeps building up and they become more finer as they get layered up, filtration becomes more difficult. So back pressure starts coming up. Okay. Then second thing is you have to pressurize to regeneration set point. Now The philosophy is that the way it has been impinged upon the surface of a cell, honeycomb cell, and it has been dropped, filter particulates have been dropped on the, if I bring a reverse pulse, I should be able to dislodge. That's the hypothesis, and that has been proven to be true. So now what you are doing is, you're just keeping it pressurized. Okay, the exhaust was going out. Now you stop that flow for a moment. So you pressurize the whole system. Okay, so this is pressure to the regeneration. So you, by experience with your DPF catalyst and by engine operations, you will come to a set point at what pressures you should block your exhaust to give you the regeneration set point. And this was the second. So the moment you did that, what happened? The reverse flow came and it took away the catalyst. I think we can go back once again. This is how the pressure, it was going up, you pressurized it, and then the reverse pulse came and the whole thing was dislodged. Okay, it's more demonstrative in terms of slides, but it is practically happens like this in the filter. The only difference here is slide is very clean. Not all the soot will get away from the filter. Some part will remain, but that will not really affect. There will be some minor pores and so minor size particulates that they will get absorbed, and the back pressure pulse, if you raise to high level pressure pulse, they will be removed. But you can't raise to that higher pulse, pressure pulse, because either you will damage the back pressure filter assembly, or somewhere else the system it will create problem. So you have to balance between that. Now, that was in principle how it works. Now, in terms of regulation is very simple. In terms of layout of the design and things like that. There is a diesel engine and the exhaust is coming, and we have a DPF which is non-catalyzed. Okay, so you save money on the catalyst of the DPF because you are not burning. You needed catalyzed DPF to burn it, and you have a vanadium SCR which is low cost SCR. Again, this is on the same brick. We are using one brick, not like 4 different bricks. We don't need any DOC. We don't need any ASC. ASC probably will be needed if we don't manage it properly. VCR, VSCR. Now, what you do here is, when you create a pulse, you also create a storage volume, because every time you dislodge the particulate matter, somewhere it should be collected. If you don't collect it, it will remain in the system. So you don't achieve anything then. So there are set of valves and set of flow pipes which go to a storage volume. The circle is shown there. Let us see what happens next. So this is what happened. The engine is running, the exhaust is coming. Okay, and it is going to the DPF. What you do is, after some time you close the extreme valve there. Okay, so now both the valves, regeneration valve as well as the exhaust flapper valve, both are closed. It means whole system is under pressurized, is under pressure momentarily. Okay. Now what happens? The moment you allowed it to pressurize, you opened the regeneration valve. The exhaust flapper valve still remains closed. So a reverse pulse is generated because engine is still working. We have not stopped engine. We have only did a little pressure balance to put system under pressure, and then allowed one channel to release the pressure. And with the release of pressure, some of the particles have moved to the storage. We are not saying all have moved. Now you close that valve. So you're back to, you're trying to now, you've done the regeneration, you're coming back to the normal. Then you will open the exhaust side. So this opens. So same thing, you came back to the original system. So this is how basically the system is. And this company in US has demonstrated few vehicles and few systems. One is that they did their first experiment was on a diesel generating set, where the experiments and the hypothesis was tried. And this is how it happened. This shows the pressure pulse. So DPF pressure generates up, and he opens that flap, that exhaust flap he closes and opens up the regeneration system, pressure comes down. The coming down of the back pressure shows that DPF has been cleaned up. Then again he allows it to build up, as it will build up in any given use, then it comes down. So like this it happens. And this is the type of assembly he has used for system. So let's do a comparison of current technologies in CPR, and then we'll move to another demonstration, which is Volkswagen demonstration. So we'll divide into, we are not differentiating now low temperature, high temperature, or low and active or high and passive. We are talking thermal regeneration, which is out of those 4 categories which I defined for regeneration, 3 belongs to the temperature regeneration, other is cool. So in thermal regeneration, you have 10 to 30 minutes of regeneration. So every time you command electronically or physically you command a regeneration cycle, you have to give at least 10 minutes or maximum 30 minutes for DPF to fully regenerate, because the whole system is built like this. In CPR, it is only 2 to 3 second regeneration. First thing you do very frequently. In the other case, you take longer to do it. But when you do it, you do for long duration. Because temperature changing, the response of temperature changing is much inferior than the response of the pressure pulse. Say in thermal regeneration, you can have up to 5% fuel penalty for regeneration. I will say none to insignificant fuel penalty for regeneration. Why I am saying insignificant? None is understandable. But what is happening is, if temperatures were low in Indian driving cycles, you will probably need some temperature rise to maintain the function of the vanadium SCR. Therefore, I am saying there will be insignificant or very low penalty compared to the other. It is true probably that dense urban Indian driving will plug filter DPF, because you will not get time, as I was explaining, 10 to 30 minutes in city driving. Once the process of regeneration starts, it has to be terminated. And why it has to be terminated? Because your next stop will come where the vehicle is not working. Next red light will come. Next crossing will come. So there will be dense urban driving will plug filter. And regeneration is independent of the engine operation. So even in the idling I can do at high speeds and anywhere. You have some news for?
Yes, sir.
Yeah, please.
Sorry, sir. So, sir, we finish by 12:40.
Yeah.
12:45. Okay. So this is for information for all the remote centers that Dr. G.K. Sharma will finish his talk by 12:45. So thereafter we'll have the question answer session and the valedictory session. Okay.
And then in thermal regeneration, to continue further, you will need some operator training for forced regeneration. Why I am saying is forced regeneration. We said in Indian driving conditions, it will not happen. That you will not get 30 minutes idle time when engine does nothing but regenerates. It comes to idle or it has to be stopped and start again. So somewhere you will force regeneration. You will tell him, go out of the city after 500 kilometers or 5,000 kilometers of run. Take 50 minutes or 50 kilometers fast speed run. So he goes to Mathura road and drives it. So unnecessarily waste fuels, disturbs the system, because that is how it has to be done. You have to force regeneration because it's not actually happening. Temperatures are not going up in the system. And here the system is pressure pulse, The exhaust itself creates the pressure pulse. So you really need a small control unit. You will need here also to give the signals. But then operator is not coming in between, because engine need not be run extra miles for raising temperatures. High temperature durability and stability will always be an issue, because if the temperatures go up, any thermal shocks will happen on the system. The silencer, the ceramic catalyst, all are subject to breakdown. Here is no temperature addition. It's a naturally occurring low temperatures of the exhaust. So durability is much better, safety is much better. Ash plugging, I think, is a case. In both the cases, it will happen. Here, a philosophy is that probably with some pressure pulse, ash will also get lifted up. But we have to really work it and see it. Otherwise, ash plugging is best handled if you use a low ash product, which oil companies are bringing up for Euro 6. Every oil company is working in a low, they call it low SPAS, low sulfur, low phosphorus, low sulfated ash. That is how they call it, low SPS oils. Passive regeneration is desired always in this case, because you need DOC. You will put DOC for that only. Here, DOC is not needed actually. You can remove DOC. And you can take it very close to the injection, to the close to exhaust manifold to take advantage. What DOC was doing, because the extreme is going away, urea injector is much lower down the line. So you needed a temperature to be risen up to that length of the exhaust catalyst. So here now you have brought down the catalyst train. The 4 catalysts has come into 1 catalyst only, SCR over DPF. And then you can remove DOC and can take urea right into the exhaust manifold. So that is how you can do it. And then capable, the conventional systems are not capable of retrofit, we talked about. While this system is both good for new engines as well as old engines. So this is how basically we are suggesting. Instead of 4 bricks, 2 injection systems. One was post-injection diesel, other was urea injection. 2 injection, 4 bricks makes system very complicated in the thermal regeneration. Here you will have only urea injection, and that too you can have very simple injectors, because you are much earlier into the line where temperatures high for urea to be hydrolyzed and make ammonia. You also have better exhaust space velocities, fast moving turbulences in the beginning of the exhaust manifold rather than after the silencers. So you can have very simple systems, and nearly every diesel engine ever made is possible of achieving Euro 6 emissions with CPR. You take a tractor engine, you take a irrigation engine, irrigation pump engine, Kirloskars, or somebody is very, very bad, old, I won't say bad, at one time they were good engines, very, very high polluting diesel engines, and you can put a CPR and then you can get a Euro 6 out of it, because it absorbs and cleans, absorbs and cleans. You can take urea injection into an exhaust manifold or directly downstream or turbine, and enables low temperature reduction. This is the same thing as I said. Now, this gentleman, Mr. Brett of US, he has demonstrated for a Volkswagen car. You know that recent news, not so recent now, but cheating in US by Volkswagen. They were manipulating results of sensors and things like that. So they were in dire need of a system which can take their engines, the old vehicles, to a new capabilities, new emission laws, without changing much of the engine and the lot population. They have to be called back to the factory. So they invited Brad to make a sort of presentation. I'm still not aware what final decision Volkswagen has taken, because they are recalling one by one vehicles. They may still fit them with conventional technology, or they can still fit them with CPR. But CPR has been demonstrated to Volkswagen to overcome their problem with Supreme Courts and things like that as a technology solution. So I see it has a lot of merit in it because it has reached that level of discussions. So what he has done, he has installed a CPR system. He has, this is the collector of the soot which gets dislodged. So he calculated that for this vehicle, Jetta vehicle, its drain period, oil drain is around 10,000 kilometers, 10 to, or I think, to 15,000 kilometers. So in 15,000 kilometers of oil drain, in the duration of run, it will generate some level of soot. Okay. So he has to optimize it. This is a 12-liter can in which he collects the particulate matter, and all that particulate matter can be then disposed of, like lubricant is disposed of, or coolant is changed, or other maintenances are done. Then this is their existing catalyst system. He has just demonstrated for this, how the train goes on. So he has DPF and SCRs here. The good advantage was for him to demonstrate this, that there is already an exhaust flapper. In our engines, the exhaust throttle does not exist. So we have some very close brother of that. Now we do exhaust braking of trucks, which is also similar to that, but it's not so so finely controlled. It's the paddle controlled and things like that to stop the trucks. In high-end trucks, not in Ace or something, but big trucks we have that. But this car has a good exhaust flapper already existing in the system, because they wanted to raise temperatures again to make their DOC work and things like that on the existing systems. So he made use of this. He could use their own exhaust flapper on the system. Otherwise, we have to provide this exhaust flapper also on Indian vehicle or retrofit systems. So then he operates the regeneration valve, and then that's how the the whole system, which I have demonstrated in the previous slides, that's how it works. Then he opens the exhaust flap, they returns to normal operation. So what he could demonstrate was total CPR regeneration completed within seconds. System returned to normal operation. The regeneration was taking 20 to 30 minutes for this vehicle. He could do it 2 to 3 minutes and it came back to normal performance. And actually there was 20% increase in horsepower and torque. This is something surprises me, but then he explained, because he was, as I told you, he was here in India and we discussed this at length. He says that after some initial operation, DPF starts filling up. So very soon, in the second or first service we call it here, vehicle's performance is reduced. And that becomes a landmark for all the time to compare, not the initial vehicle performance. And if he keeps his system very clean since beginning, which is CPR technology does, that he doesn't allow any particulate to actually accumulate there first. So he could achieve in the first service or second service period a 20% increase in the horsepower. And the vehicle could come without active thermal regeneration over 200 kilometers. He could see that he needed an active or thermal regeneration, which would have needed a 2000 kilometers. He could do it. He actually never needed a cycle for temperature generation, thermal generation, because he is a cooled system. So he just continuously keeps doing. He doesn't take that, run over 2000 kilometers and then start active regeneration. Testing is ongoing there. Fixed for Volkswagen, their problem with this engine, and he's trying to fix a problem of that. So let us come to the summary of this my presentation. I'm almost close to finishing. Say Euro 6 engines, which is international engines, the non-EGR. So there are systems which are EGR. I said MAN uses EGR based and SCR both. So in non-EGR Euro 6 engines, vanadium based SCR solutions are found most cost effective. I had few slides, but I think that will not be of interest to you to know how much cost is this. But I can supply you those information if you need. So they are found most cost effective in fuel consumption and also in urea consumption. As I said in the beginning, the truck industry or the bus industry will look at it, the total cost of the operation. One is the capital cost. Okay, that you pay one time. But then how do you maintain and what is the operation cost? So Scania follows this. They use a non-EGR engine. They use a vanadium catalyst. They use a pulse temperature regeneration. They don't use CPR. They are the most fuel efficient engine. 20% I think lower than their competitor, which is a big thing actually in the international scenario. In conventional approach, low temperature pulse based DPF regeneration is possible in all driving conditions and is compatible with vanadium SCR. So this is what we have already concluded in conventional approaches. Cooled particulate regenerator technology is very promising. It is based on pulse pressure and efficient energy versus heat based regeneration. I think the most important point of this technology is that you need not increase the heat, which in principle is not wrong because others are doing it. But for Indian conditions where our driving temperatures, driving conditions are different, the temperature of this exhaust system is going to be very low. You will have to put much more heat than what our counterparts in US and Europe do for their trucks. They have long overhaul trucks, long, they keep running in 90, 100 kilometers an hour. So we are different. So that's why the fuel economy advantage will be much seen here, much higher seen here in CPR technology. Then what we are saying is that you have a vanadium SCR coated over DPF as a simple solution, use CPR, and this will become most cost-effective technology that can take all of India's new and existing old engines to BS6 with current fuel, which is 350 ppm. Or even if you bring 50 ppm sulfur, for which the refineries are already taking decision, it will still remain the cost-effective. If BS6 after treatment is based on vanadium as CPR for DPF regeneration, India need not spend in refineries to produce ultra-low sulfur diesel. That is what I say, but I have lost this statement now virtually on day fairs because we are already taking decision to go for ultra-low sulfur diesel. That's the end of my talk.